KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In this class, we start with the problem number 19. See here. What is the de Broglie wavelength of a nitrogen molecule? What is the de Broglie wavelength of a nitrogen molecule in air at 300 Kelvin? In the that is what one of the assumptions they have given. See here. That is what assume that the molecule is moving with RMS speed. So that is what root mean square speed of molecules. Root mean square speed of molecules, right? He is moving with molecules at this temperature, right? Assume that the molecule is moving with the RMS speed of molecules at this temperature. Okay, right. See here in the bracket, atomic mass of nitrogen given as 14.0076 U, and then K value given as 1.38 into 10 to the power of minus 27. 1.38 into 10 to the power of minus 23 joule per Kelvin. Okay, right. So what I am saying is here, what is the de Broglie wavelength of a nitrogen molecule in air at 300 Kelvin, right? So at this temperature we have to calculate de Broglie wavelength, right? At this temperature we have to calculate de Broglie wavelength. So afterwards, see here so first you try to understand the problem, what they have given and what we need to find. So he is asking to find de Broglie wavelength of a nitrogen molecule in air at 300 Kelvin temperature, right? So regarding that they have given some information, and they also given one of the assumption, that is what the molecule is moving with the RMS speed of molecules at this temperature. So root means square speed. Okay, root means square speed. Okay, next they have given two values. One is atomic mass of nitrogen 14.0076 U, and K value as 1.38 into 10 to the power of minus 23 joule per Kelvin. Okay, right. See here, see the problem, see the answer. Mass of nitrogen molecule, first mass of nitrogen molecule we are going to calculate, that is small m is equal to 2 into, right? See here, 2 into, and this value 14.0076 into, this is what 1.66 into 10 to the power of minus 27. This is what 1.66 into 10 to the power of minus 27 kg. Okay, then finally what is the mass of nitrogen molecule? It will be 46.5 into 10 to the power of minus 27 kg. 10 to the power of minus 27 kg. Okay, right. And temperature already given as 300 Kelvin. Now we are going to derive a formula for de Broglie wavelength, because he is asking to find what is de Broglie wavelength, right? Okay, and you know, regarding the gas container or regarding the gas molecules, okay, here nitrogen molecules, right? So regarding the nitrogen molecules, you know what is the expression we can write here? Average kinetic energy Average kinetic energy of mc square is equal to 3 by 2 kT. Average kinetic energy 1 by 2 mc square is equal to 3 by 2 kT. Okay, right. So when it is equal to 3 by 2 kT, so we can write C as a subject, no, right? We can write C as a subject. C is equal to square C here. These two will get cancelled because here also 2 is there, here also 2 is there, and mathematically we are writing C as a subject. Then C is equal to square root of 3 kT by m. 3 kT by m. Okay, right. Afterwards, therefore lambda is equal to, the de Broglie wavelength formula, lambda is equal to h by p. Lambda is equal to h by p, right? So p is equal to mv, no? So here c is the velocity. So lambda is equal to h by mc. H by mc, okay? So when lambda is equal to h by mc, that is equal to h divided by square root of, in place of c you write this value, square root of 3 kT by small m. Square root of 3 kT by small m. Therefore lambda is equal to h by mc. In place of c we have to write this value. Then finally we are getting this expression, that is what small h by square root of 3 m kT. Small h by square root of 3 m kT, right? And you substitute the values, you substitute the values what they have given, right? So what are the values? Here you can substitute the value of h, Planck's constant 6.63, right? 6.63 into 10 to the power of minus 34. Actually joule second we are taking in SI unit, right? Then no problem. Afterwards you just see here, that is what the value of 3 is as it is constant, and mass value here we calculated 46.5 into 10 to the power of minus, right? 46.5 into 10 to the power of minus 27 kg into k value 1.38 given, 1.38 into 10 to the power of minus 23, and t value, right? T value is here, observe carefully, t value is 300 Kelvin, right? 300 Kelvin, and then finally in meters, okay? So you substituted, you calculate all these things. So mathematically first you go through the square root and then you just divide this value. Then finally we are getting, this is what 0.028 nanometers, right? Actually this is what 10 to the power of minus 9 meter, and you know very well this 10 to the power of minus 9 meters we can replace with nano. We can replace with nano, okay? So that what I am saying is here, after completion of the calculation, right? After completion of the calculation, we are getting finally 0.028 nanometers as de Broglie wavelengths according to the given values. Okay, right. So in this question, if you concentrate once again, if you overlook once again, he is asking to find de Broglie wavelength of a nitrogen molecule in air at 300 Kelvin, right? Given one assumption, that is what the molecules are moving with root mean square speed at this temperature 300 Kelvin, and given atomic mass of nitrogen and K value also, right? So first we calculated mass, that is what small m, and for N2 molecule, that is we got 46.5 into 10 to the power of minus 27 kg. Thereafter, by this expression, that is what average kinetic energy equating to this condition for gas at a given temperature. We are writing C as a subject, then C is equal to square root of 3 kT by small m, okay, right? Therefore lambda is equal to h by mc. Lambda is equal to h by mc. Therefore next, just in place of C we are writing this value, right? Then by substituting the given values and the thing what we calculated small m, finally we are getting the de Broglie wavelength, right? De Broglie wavelength of a nitrogen molecule in air at 300 Kelvin we are getting as 0.028 nanometers, okay, right? Next problem, that is what problem number 20. See here, So regarding the problem number 20, there are two things, A and B. So first I will explain you the question and then we will go for solution. See here. See this carefully. Regarding the problem number 20, A. Estimate the speed with which electrons are emitted. Estimate the speed with which electrons emitted from a heated cathode. From a heated cathode of an evacuated tube. Of an evacuated tube impinge on the cathode, impinge on the anode, right, maintained at a potential difference of 500 volts, maintained at a potential difference of 500 volt with respect to the cathode. I will repeat once again the sentence, you please be concentrate. Estimate the speed with which electrons emitted from a heated cathode of an evacuated tube impinge on the anode maintained at a potential difference of 500 volts with respect to the cathode. Okay, full stop. Ignore the initial speeds. Ignore the initial and small. So ignore the small initial speeds of the electrons. Okay, he is asking to consider this one. Right. Next, the specific charge of electron. The specific charge of electron, that is, its E by m is given to be 1.76 into 10 to the power of 11 coulomb per kg. Coulomb per kg, right? This is what E by m value what they have given, right? So the specific charge of an electron, that is, its E by m is given to be 1.76 into 10 to the power of 11 coulomb per kg, right? So regarding the A in 20th question, he is asking to estimate the speed of the electrons emitted from a heated cathode in an evacuated tube impinge on the anode maintained at a potential difference of 500 volts with respect to the cathode. Okay, right. And regarding that, this is the point he is asking to consider, and this is what the given value E by m is 1.76 into 10 to the power of 11 coulomb per kg. Next, B. See here, use the same formula. Use the same formula you employ in A to obtain electron speed for an anode potential of 10 million volts. Okay, 10 million or 10 mega. What is this value? Is 10 power 6. So 10 MV, right? Full stop. Do you see what is wrong? Do you see what is wrong? So we have to talk about the possibilities. Then, in what way is the formula to be modified? In what way the formula is to be modified? Okay, so he is asking how we need to modify the formula. Okay, right. See here. So first we will discuss A and then we will go for B. See here and listen carefully. First, we have written here the given values, because V is equal to 500 volts and E by m is 1.76 into 10 to the power of 11 coulomb per kg, and V is equal to question mark, right? Okay, and we are equating these two. This is what kinetic energy, and this is that what we are getting, that is what the product of E and V, right? It is also energy only, no? Once you just back to that, that is what work function, right? Work function means that is also EV only, no? Right? EV only, no? So EK is equal to half mv square is equal to E into V. Here we are writing V as a subject, ma. So V is equal to square root of 2 EV by m, right? Okay. Now this is what 2 into E by m into V. 2 into E by m into V. So 2 is okay, right? E by m value they have given now 1.76 into 10 to the power of 11 into V value is 500 more. V value is okay. Here only written V value is 500, and then finally we are getting 1.33 into 10 to the power of 7 meter per second. 1.33 into 10 to the power of 7 meter per second. This is what speed with which the electrons emitted from a heated cathode in an evacuated tube impinge on the anode maintained at a potential difference of 500 volts with respect to the cathode. Okay, so this is what basically speed of electrons right, we use the given information, right, that is what V value and E by M value also, and we also used the assumption, that is what ignore the initial or small initial speeds of electrons, right. Next one, that is what B here only. So here they changed the potential difference now, that is what 10 million volts, so that you can write it as 10 to the power of 7 now, because it is 10 to the power of 6 ma. So it is 10 to the power of 7, right, it is 10 to the power of 7 volts. Now see the same formula, whatever we are using here, the same formula you have to use. So 2 into E by M value is also same, and in place of V we have to write 10 to the power of 7. Then finally we will get it as 1.88 into 10 to the power of 9 meter per second. 1.88 into 10 to the power of 9 meter per second. Okay, this is what the speed of the electron. This is what speed of the electron. Okay, right. And by seeing this value, that is what the speed of the electron, we can say that the speed is not possible, because you know Einstein's theory of relativity, and some of the predictions are saying that the maximum speed, the maximum possible speed in this entire universe is speed of light, that is what 3 into 10 to the power of 8 meter per second. Okay, right. So this speed is not possible because no particle can have, this speed is not possible because no particle can have a speed greater than the speed of light, greater than the speed of light, that is what C is equal to 3 into 10 to the power of 8 meter per second, right. So what can we say? The above formula for kinetic energy is valid only when V is double less than C, right, when V is double less than C. And one more thing is, at speeds comparable to the speed of light, we need to use the relativistic formula. Just now I told you, Einstein's theory of relativity. So when the speeds are comparable to the speed of light, we need to use the relativistic formula, that is what Ek is equal to mc square minus m naught c square. Mathematically you can take c square as common, m minus m naught into c square, or Ev is equal to, because it is Ev no, Ev is equal to m naught c square, by square root of 1 minus v square by c square, right, minus m naught c square, right. Observe carefully what we are writing here. Next step, Ev by, and we are taking this m naught c square as a common and taking this left hand side. So Ev by m naught c square is equal to, this is what 1 by square root of 1 minus v square by c square minus 1, or Ev by, so this and all mathematical right. So conceptually we are writing this one, and from this we are getting this, and then we are substituting the values, that is what m is equal to m naught by square root of 1 minus v square by c square, that only we substituted here, right. And thereafter mathematically we are taking, that is what common, and sending to the left hand side, and then finally taking this minus 1 to this side, that is what plus 1 is equal to 1 by square root of 1 minus v square by c square. Okay, right. Afterwards we are going to substitute the values, right. So this is what right hand side, and this is what this is what left hand side, and this is what right hand side, right. So we are going to substitute to get V in terms of C, right, to get V in terms of C, right. So see here, if you complete that mathematical process, we are getting that V as, right, V as 0.999 C. So what does it mean? So almost it is like 1, no? So V is equal to C. That's why what he is saying is, when the speeds are comparable to the speed of light, when the speeds are comparable to the speed of light, you please use this formula, that is what Ek is equal to mc square minus m naught c square, mc square minus m naught c square, right. Next question, see this one, that is what question number 21, see here. Here also we have two things, A and B, right. So first I am going to discuss A and then B. A monoenergetic electron beam with electron speed of 5.20 into 10 power 6 meter per second is subject to a magnetic field of 1.30 into 10 to the power of minus 4 Tesla. 1.30 into 10 to the power of minus 4 Tesla, normal to the beam velocity. Normal to the beam velocity. Full stop. What is the radius of the circle traced by the beam? What is the radius of the circle traced by the beam? Given E by m for electron equals to 1.76 into 10 to the power of 11 coulomb per kg. Right? It is a constant value, but anyhow they have given. Right? So once you look at the problem, that is 21. First a monoenergetic electron beam with the electron speed of 5.2 into 10 power 6 meter per second is subject to a magnetic field of this value 1.30 into 10 to the power of minus 4 Tesla. Normal means theta is equal 90 degrees to the beam velocity. Full stop. What is the radius of the circle traced by the beam? Given E by m for electron equals to 1.76 into 10 to the power of 11 coulomb per kg. Next, that is what B. See here. Is the formula you employ, right? So the formula you employ means we used. Is the formula we used or employ in A valid for calculating the radius of the path of a 20 million electron volt electron beam? If not, in what way it is modified? If not, in what way it is to be modified, right? That is the question. Okay. See here. See this, ma? So in the second B, what he is asking, the formula what we used is valid for calculating radius of the path with this value, with this energy value, that is 20 million electron volts of electron beam. If not, asking to say how should be modified, how it should be modified, right? First we are going for A, to calculate, right, to calculate radius of the circle traced by the beam. See here, this is what first what are the values they have given in this problem? Okay, first A, speed V is equal to 5.2 into 10 power 6 meter per second, and magnetic field B is equal to 1.3 into 10 to the power of minus 4 Tesla, and E by m value is 1.76 into 10 to the power of 11 coulomb per kg. Theta is equal to 90 degrees. Theta is equal to 90 degrees, right? So these are the values they have given, right? So 1, 2, 3 and 4 values they have given, right? Now we have tried 4 values. Afterwards, what I am saying is, the normal magnetic field provides necessary centripetal force to the electron beam so that it can trace a circular path, right? In the chapter magnetic effects of electric current, we experienced what happens when the electron enters into a magnetic field at different angles, and moreover regarding the balancing of forces, right here, that is what the force on an electron due to the magnetic field provides necessary centripetal force for an electron, which makes the electrons to move in a circular path, right? And you know that formula F is equal to QVB sin theta from the chapter of magnetic effects of electric current. So just in place of Q we have written E here. Finally EVB sin 90 is equal to mv square by R, right? And the same thing, cos 0 sin 90 is equal to 1, right? So EVB is equal to mv square by R. So V and V square is here. So here V will be removed and here V will be the same like that only. Finally R is equal to mv by EB and V by E by m into B. We didn't do anything here, just we modified, we changed the shape of the formula. Just this m we are writing here E by m into B, right? Now we are substituting the values what they have given. One is the speed of the electron, another one is the magnetic field value, another one is E by m, and theta value already we substituted here itself, right? So finally we are getting 22.7 meters as the radius of the 22.7 meters as the radius of the circle traced by the beam, okay, right? Next B, see here, no, the answer is, what is the question? Is the formula you employ in A valid for calculating the radius of the path of a 20 million electron volt electron beam, right? The answer is no. See here. The formula R is equal to mv by qb is not valid for calculating the radius of the path of the electron beam, because such high energy electrons have velocities comparable to the speed of light. So for this we should use the relativistic formula. That is what in place of m we have to write m naught by square root of 1 minus v square by c square. M naught by square root of 1 minus v square by c square. This is the formula we have to use to calculate regarding this much of energy, that is what 20 million electron volts for an electron beam. Okay, right. So in this class regarding question number 20 and 21, he is checking the possibilities. Okay, so you just keep in mind 20 and 21 problems are important for us when we are going to deal with the problems related to competitive exams. Okay, right. In this class we discussed 3 problems, 19, 20 and 21. In our next class we will continue with next continuation problem, that is what problem number 22. Okay, thank you.